the interesting thing in your model would be to find the price of something not traded from things which are traded. Exactly. But the first question is how do you find the prices of the correct prices of things which are actually traded?
Well, you look at the market. We got the prices from Bloomberg.
Yeah, okay, so you have the prices from Bloomberg.
Yeah, you need the quotes, yeah.
Okay, but the thing is that if you do those things of incomplete markets, because you say that the models that we use generally are not correct, and that pricing exotic
I didn't want to criticize your models. I was just saying that if the market is incomplete, then here's one way to do it. Indifferent.
Wouldn't there be a way for you to find the price of just like a vanilla option and compare it to what you see in Bloomberg?
Yeah, that's what we did. Yeah, I didn't emphasize that. That's exactly what we did. We took one of the quoted options, and then we took it out from the set of hedging instruments, and then we priced that.
From the others?
Yeah, we used the other options to hedge one of the options. And I didn't mention, but in the figures that I showed, I actually had the bid and ask quotes for the option being priced. We didn't use it in the hedging. Otherwise, the price would have been exactly the quote.
Okay, Bruno?
Thank you. Yeah, it's for Marco. So I must say I really liked it very much because I think it's very important to focus on this notion of let's say martingale measure as opposed to equivalent martingale measure for all practical applications. For instance, you have a trader who would pay attention to strategies that are not referring to any initial measure, and the notion of arbitrage really would be more point-wise. And so arbitrage de la classe S allows you to sort of release the condition of having a positive probability when you make money here. You just defined a subset of sets. Yeah. In the case of the Hobson arbitrage, so I guess in that it's a case where there is no martingale measure actually, and it's so is it correct to say that in your terminology it is an open arbitrage but not a model-free arbitrage?
Exactly. It's an open arbitrage but not a model-free. And the equivalence among all the conditions I mentioned was with respect to this enlarged filtration, because otherwise you see you can. That was an example which comes out from practice, so to speak, where assuming they have the same price. But we gave in the paper a very simple one-period model where all these possible equivalents do not hold unless, because there is this situation where there must be some form of arbitrage, but until you don't know what is P, which is the agent, you cannot formalize. But we are trying to aggregate them all, and this is possible at the price to this technical enlargement. But then you can re-extract, as soon as you tell me which is the probability, I find in this multi-set varied process which is the one that is the arbitrage for that given probability.
Yeah, thank you very much.
There was a question there. Okay, so George?
No, I just wanted to perhaps ask a kind of question that's more like a suggestion of complementary work, and we just saw a very nice, let's say, theoretical ideas from Marco's side, and perhaps very practical ideas from Temu's side. So perhaps my question to you, Marco and Temu, is: do you think that perhaps you can join forces and obtain some practical algorithm that could be used directly into the market?
Now, well, I must say that in difference price have been studying for a while, right? And also it can be written as a convex risk measure if you are a coherent or a convex, depending if you add a penalty or not. This has been done, and also it's called risk measure, market adjusted risk measure if you want to try to hedge the claim, not only by investing in the bond, but also by using some instrument which maybe are conic or are convex. And so I think this can be done, and there is no. However, the point is that as soon as you have a criteria which is a subjective criteria, you believe in that probability, you believe in that utility. So of course you have to choose at some point. Either you believe or you don't believe. If you believe and you use indifference price, then it makes sense. I did it also for many years before, and then it's a selection. Right? It's your point of view that enter in, because in incomplete market, otherwise you have this no arbitrage interval, which now, okay, in the model-free context, we try to represent in such and such a way. But I think in the case of indifference price, at least as I understand it, and as it was defined by people before and used, you need this subjective criteria. So maybe it's only in the constraint that you can do probability free, not in the objective function, because by definition is your own.
Yeah. So I always thought this as sort of a complementary approach. What I would try to emphasize here was the subjectivity, that it should be in the model, because whenever you trade in practice, you trade according to your beliefs and preferences and financial position. Whereas I'm not saying, when I said that the arbitrage doesn't really matter, I didn't actually know what you're going to talk about. I didn't mean it in a bad way. I think what these kind of model-free results give, they give sort of results on the robustness of the model. And I think that's very useful information when you build these models which are subjective. You should have an idea of how sensitive your results and models are when you perturb the model. And I think that's where these kind of robustness results can be useful.
But about practicality, I must say that it's pretty much impossible to really find on the market an arbitrage, notably due to the bid-offer, the bid-offer spread. But interestingly, the bid-offer spread gives you the opportunity to apply this kind of techniques to improve some prices. I'll give you an example. If you're a customer, you want to buy a call spread like the K1 call minus the K2 call. So if you do it directly on the market, you will have to pay the high price on the offer on K1 and receive only the low price, the bid on K2. Mm-hmm. And actually, it does happen in reality that often it's better to use alternative strikes that have better bid-offer spread,
okay.
And in such a way that, so typically instead of buying the whole call spread K1 minus K2, you may use K0, which is lower, and maybe to have K0 minus K2, all this divided by 2, and actually you do get in practice better prices. Yeah. So it's you compute the cheapest super application, and so it means you will pay less for this product, and it's a better product. You pay less now, and you may get more after because it's dominating the profile. And a second comment is that actually for instance, for exotic options, so it's very important to compute this arbitrage, this super replication prices when you can use other existing options, because then you get often very competitive prices as opposed to do it just, I mean, in most of the simple examples, the super replication price you get are ridiculous, like you have to pay 100 for a call which has a market value of 4 or whatever. Yeah. But actually, if you use really other traded instruments that are quite close to your target, you can get very competitive price, and often good enough to be able to sell to a client the complex product at a competitive price because you have explicitly the vanilla hedge.
You actually see that in the results we got. We used these 100 or 200 options, whatever. And actually, I didn't show it here, but in almost 50% of the cases, we used closing prices from Bloomberg. You get model-free arbitrage because we have this buy and hold strategy. And you can find what with optimization. You end up with some It's more complex than put call parity. So you get some non-trivial portfolios that cost nothing to buy, take into account the bid-ask spread of the closing prices, and which do have non-negative payouts which are positive somewhere.
We can check. I mean, usually when you observe something like this, it's because it's wrong data or non-synchronous.
It's from Bloomberg.
Because, yeah. I'm not here to say anything bad about it, but yeah, it's not always perfect. But again, my point is that you can improve, you can lower the price of something you had decided to buy by doing things like this, but you will pretty much never manage to really buy something and sell something. I mean, extracting, really creating an arbitrage. Basically, you cannot make sure money, but you can improve the price you would have paid for a certain product.
I should just a short observation. Matteo has a paper on transaction cost. So these models with transaction cost to see how all this notion can be used, and it works.
So,
it's a preprint.
And I think related to that, if you want to improve your prices, it's often enough if you allow a little bit of downside risk to be able to improve the prices a lot. So instead of being completely hedged, you're like acceptably hedged.
okay, so in interest of time, I've meant to ask you to continue the discussion on the coffee break. And let's take the speakers once again. Resume for